problem that we are solving is problem 4, the time of death estimation. This problem uses these observations and Newton's law of cooling to estimate the time of death of the corpse at the crime scene. So we're going to begin by simply finding our differential equation. So using our explanation here of Newton's law of cooling, we can see that the rate of heat loss of a body is proportional to the difference in temperatures between the body, T, and its surroundings, S. So that gives us the following differential equation, which is the change in temperature over the change in time, which is proportional to the difference between the temperature of the body and its surroundings. We can also assume that this K factor here is negative because we will be decreasing since we're cooling. So we can recognize here that this is a separable first order differential equation, which we saw in topic 2 of the lecture notes for differential equations. So using that method, we can rearrange this to the following form. It would be 1 over t minus s dt equals negative k dt. Now, integrating both sides, so we can solve both of these directly. So this is just going to be the log of t minus s negative k t plus some constant. So we're going to be rearranging the log over here. So we're going to t minus s is equal to e to the power of negative k t. And so because e to the power of negative kt plus c is the same as e to the negative kt multiplied by e to the c, our e to the c factor can simply just simply be a constant. So we can change this to t minus s equals a e to the power of negative kt. And now if we add s to both sides, we're going to get t is equal to some constant multiplied by the e to the power of negative kt plus the surrounding temperature. So this here is going to be our differential equation. Now if we go back to the problem, we can now have a look at some of the information that we've been given so that we can try and remove some of these constants here. So we've been told that the air conditioner was running steadily at 21 degrees Celsius and that all the windows and doors are closed in the hotel room. So we can assume that our surrounding temperature is going to be 21 degrees Celsius. We can also see here that the temperature of the corpse was 27 degrees Celsius when it was found at midnight. So let's assume that midnight is going to be our T0. So when T equals 0, so kind of like 0 AM, our temperature is going to be 27. And then this one here tells us that at when the corpse was 25 degrees, this was at 2 AM. So it's going to be 2 hours later. So when T equals 2, the temperature at that time is going to be 25. So using this information here, we can put these into our differential equation here. So when T equals 0, the temperature at that time is equal to 27. So let's sub in some of our values here. And we also know that S equals 21. So 27 is equal to A times e to the power of negative k naught plus 21. So we can subtract 21 from both sides, and that's going to give us 6 is equal to A, and we know that e to the power of 0 is just going to be 1, and so therefore A equals 6. So now we just need to figure out what k is. So if we use that other bit of information, when T is equal to 2, the temperature at that time is equal to 25. So let's sub in these values here. We've got 25 is equal to 6 e to the negative 2k plus 21. So rearranging, we've got 4 equals 6 e to the negative 2k. Divide both sides by 6, so we're going to get 2/3 is equal to e to the power of negative 2k. And so using our log laws, negative 2k is going to equal the log of 2/3. And so therefore k is going to equal negative log 2/3 divided by 2. And so therefore, we'll just use decimal there, therefore k is approximately 0.2027. Now we've found all the constants, so now our differential equation is going to be this. The temperature at some time is going to be 6 times e to the power of negative 0.2027 t plus 21. So now we've also been told that we can assume that the temperature of a living person is 37 degrees Celsius. Now that we have our differential equation, we want to be able to solve at what time did that person die. So we can assume that when the person dies, they're still going to be at 37 degrees Celsius. So we want to find when the temperature of some time is equal to 37, what time is that? So substituting in these values here, so we've got 37 equals 6 e to the power of negative 0.2027 t plus 21. We'll subtract 21 from both sides, so we get 16 equals 6e to the power of negative 0.2027 t. Divide both sides by 6, so we'll have 8/3 equals e to the power of negative 0.2027 t. Rearranging again using our log rules, we've got negative 0.2027 t equals the log of 8 on 3. T is going to equal the negative log of 8 on 3 divided by 0.2027, and so that's going to give us that t is approximately negative 4.8. Let's go 8479. So now what we can do is, if we subtract this time from midnight, which is our initial time at t equals 0, we put this into hours and minutes. This is going to be approximately 4 hours and 50 minutes. So therefore, the corpse has died 4 hours and 50 minutes before midnight. Therefore, the corpse must have died at 7:10 p.m., which is 4 hours and 50 minutes before midnight.